Assalamu alaikum, dear students. So we have calculated this. This is basically from the first of this first Maxwell equation that lambda dot e equal to rho by epsilon naught. So we can write it in this form, taking it x, y, and z component because it is clear that when we write that partial even, so even is basically that's our f10, right? Because we have that even is this one. So this is when you write that nu equal to 1, mu equal to 0, right? So this corresponds to even, and similarly we have that E2 that's equal to F20 and E3 equal to that's F30. So these corresponds to different components of that this electromagnetic field tensor. And as I already told you that this electric field, it when you make transformation from when you go from one frame to another frame, inertial frame, so this changes sign because we have that. If you write the covalent of this F unit, so it will only the electric field will change sign. So you can have this plus Ex plus Ey and plus Ez and minus sign on these minus on this element minus E1 and minus Ez. So that means only this electric field change sign under the transformation when you move from one inertial frame to another inertial frame. So we can say that this electric field it is called that polar vector. Huh? So this polar vector. So E is the polar vector. And similarly, if you talk about this magnetic field, so that means if you write the covalent form of this electromagnetic field tensor, so this will be, so it doesn't change its sign. So you can have this will be minus Bz, By plus Bz, so these remain the same. So in that case, this magnetic field, it remains invariant under the transformation from one frame to another frame. So it's called an action vector. सो एज ए ये मैंने ऑलरेडी आपको कहा था कि मतलब व्हाट इज एक्शन एंड पोलर वेक्टर जो इससे पहले वीडियो था. तो अब हम क्या करेंगे. सो व्हाट आई रोट हियर, तो आई यहाँ पे मैंने इलेक्ट्रिक फील्ड लिखा इन टर्म्स ऑफ दैट इलेक्ट्रोमैग्नेटिक फील्ड दैट राइट. सो आई कैन रिराइट दिस इक्वेशन. सो आई कैन रिराइट दिस इक्वेशन एज partial 0 f00. ओके. सो दिस इज इक्वल टू दैट सी रो म्यू नॉट. ठीक है. तो मैंने यहाँ पे क्या किया बेसिकली, मैंने ये टर्म इंट्रोड्यूस की F00. दैट मीन्स जब हमारा म्यू भी जीरो होगा म्यू भी जीरो होगा. सो दिस कॉरस्पॉन्ड्स टू अवर दीज डायगोनल एलिमेंट्स. तो यू कैन सी फ्रॉम दिस determinant our when you are mu equal to 0 or mu equal to 0, so you have 0, then F00 will be 0, F11 will be also 0, F22 will be 0, and F33 will be 0. All these diagonal elements will be 0. So by adding this term, so it doesn't affect our equation, right? So ये मैंने simply इसको add किया in order to incorporate, because we know that when we discuss that this Maxwell's first Maxwell equation, so that as I already told you, it is time independent equation because we have that lambda dot E equal to rho by epsilon naught, right? So because it is independent of time, right? So that's why we are getting only the three components. Now I can introduce, because I need to write the covalent form of this Maxwell equation, right? So for that, because when we write this in covalent form, so it contains those four components. So I need to introduce this time component here also, right? So that's why I put this term. So इससे कोई effect नहीं पड़ेगा equation. So instead of that, because when you write this, because we have now partial 0 that corresponds to a time component, and this is x, y, and z component, right? So or you can write this as, this will be that partial mu, right? Yeah, mu. So that will be equal to c rho, right? Because if you take that mu equal to 0, 1, 2, 3, or mu equal to 0. Take all possible values, because when you take that 0, 0, this gives you the first component, and 1, 0, 2, 0, 3, 0. So all these possible combinations, right? So, but instead of that, because we have this for time component, we have that J0 equal to, we have this J0, this is the current density, the time component, because we are talking about what we have calculated this one. So if you remember that, so we calculated from that four-dimensional current density, right? Then we take that four-dimensional current density, right? So this is the time component of that current density. So this is equal to that 0, right? So instead of that, I can write this as partial mu. Now if you compare that, तो अगर हम क्योंकि हमने already वो derive किया था कि so we are getting that, so instead of this mu 0 we are getting there 4 pi by c, right? So that's to say, right? So it's simply a constant. So this is the coherent form of this Maxwell's equation, right? So that our equation was that nabla dot E equal to rho by epsilon, right? Now in my previous lecture, जो previous video था उसमें मैंने आपको बताया था कि we can we can combine these two equation Maxwell, first Maxwell equation and fourth Maxwell equation, right? So fourth, that is basically that nabla cross E equal to that mu 0 j plus 1 by c square partially by partially, right? So we can combine that equation with this equation and write it in this compacted form, right? So this is what we have done for this. ये में हमने किसके लिए किया था? First Maxwell equation के लिए, right? So let us write now the second Maxwell equation, fourth Maxwell equation. Okay, so this is our FU. Okay, so let's write now that equations, because our Maxwell fourth equation, that is our nabla cross B, that's equal to mu 0 j plus 1 by c square So this is Maxwell's fourth equation, और जिसको हम कहते हैं कि this is the modified form of this Ampere's law, right? We know that this is a time dependent equation, because we can write that this is how this magnetic field is produced due to the combined effect of that current density and that electric field, right? So when you take its direction with respect to time, so it's the combined effect of that J and E that gives us how this magnetic field is produced. So this is our Maxwell's fourth equation, and let us rewrite this equation first. So I can write this equation as, so this I can write as minus 1 by c square Okay, let me write this down first. Okay. So let us write this in component form, because So this electric field, it has that x, y, and z component, right? So let's write that minus 1 by c square, partial by partial t. So this is, it comes from this, from the first term of this equation. And similarly, I can write this as plus gamma cross b.